Hi again. In this video, I will be talking about the three different times that we will be using in a time study. These are the observed time. The observed time is simply the average of the recorded time. So we record the time, we take the average, that would be the observed time. The normal time is the observed time adjusted for the worker performance. Sometimes the performance sometimes doing well, sometimes does not do well. So we have to adjust the normal time. We have to adjust the observed time to the normal time by multiplying it by the performance of the worker. It's computed by multiplying the observed time by the performance rating. So again, the observed time times the PR, which is the performance rating. So this here, whether it's giving to you or you can calculate it by the normal performance divided by the observed performance. You observe the worker for a few times and you say, okay, well, he's performing at 90% basically, or oh, he's performing at 120%. So this is where you do. So one more time is the observed time times the performance rating. Now, the standard time is the normal time. Basically, when we talk about the normal time, we don't look into some factors, basically the delay, whether it's personal delay or an avoidable delay, or maybe rest or breaks. We did not consider that. So the standard time will need to look into these different delays, such as getting a drink of water or going to the restroom, machine adjustment or repairs or talking to the supervisor. These are not considered with the normal time or the observed time. These are need to be considered, and therefore we need to multiply the normal time by what is called the allowance factor. The allowance factor, it is calculated for whether for each step or for the job overall, for the specific job or for the process overall. And we'll talk about this in just a second. But let me explain in more details. This chart will help you understand the difference between the different types of times. So now we have different allowances, such as constant allowances, variable fatigue, unavoidable delays, special allowances, such as policy allowance or work allowance, basic fatigue, personal needs. These all added to be as a total allowance. Now we add that on the top of the normal time, that will give you the standard time. Okay, so the standard time would be the normal time plus all these allowances time. And remember that the normal time would be basically the observed time times the worker performance. Now let's move on to an example here on differentiate the two different allowances. We have again two different allowances. One is based on the job time, and the other one if we have a different job but have only one allowance. So one more time, this equation we use it if we have it just for the job, for a specific job, which is part of the process. Or we could use this equation if we have an allowance rate for all the process, including the steps, so not a separate one. All right, so let's take a look into this. Compute allowance factor for these two cases. The allowance is 20% of job time. The second one, B, allowance is 20% of work time. A is 20%. So if we're doing for the specific job, for just one task of the job, that would be 1 plus 0.2, that would be 120%. If we're doing the 20% for the whole process, then that would be 1 divided by 1 minus 0.2, that would be equal to 125%. Again, this is the difference between them. Now, if we're doing with the whole process, let's say the whole department, so this is the allowance. If you're talking about a specific machine or a specific task, you need to use this one. These allowances also published online, and there is a table in the textbook where I took this table from, will tell you about how percentage that are acceptable. So for example, personal allowance would be 5%, basic fatigue would be 4%, Variable allowances would be include the 2%. All right, what else? Use force or muscular energy. That would be based on the pound. 5 pound would be 0 allowance. 10 pounds, that would be 1%. 15, and goes on and on. Bad lighting, if it's very inadequate, that would be 5%, etc. So there's some allowances table published online and in textbooks such as the textbook that you're using. All right, now let's take a look into how we could calculate the observed time based on this case study or time. The example 3, a time study of an assembly operation yield the following observed time for one element, remember, this is just one element of the job. And this is important because this is when we do the allowance, we need to know exactly, are we talking about the whole process or just one element, one step? So they're talking about one element, which give a performance rating of 1.13 using allowance of 20% of job time. Determine the appropriate standard time for this operation. So we have 9 observations. As you see, we timed all of these. Total is 10.35. The first thing I want to do is find the average. The observed time would be the 10.35 divided by 9. So that would be 1.15. Normal time would be the observing time, which is 115 times the performance rating, which is 113. So that would be 1.3. And now for the standard time would be the normal time, 1.3 times 1 plus A, because this is just for one element. So 1.3 times 120, that would be equal to 1.56 minutes. So the standard time for this process to be 1.56. Even keep an eye on the observed time is 115. That's the average time. So the 1.56, why it's more? Because we give some allowance and performance and so on. All right, now let's take a look into another example on observing pizza preparation and at a pizza place, Pat's Pizza Place. To determine the number of observation need, we take some initial observation of the job being studied. In this case, let's observe how long it takes to prepare a large hand-toasted pepperoni and cheese pizza. We began by taking 10 observation, 10 observation of each of the 7 elements. The elements are the standard deviation of the observed time and mean observation of the time shown in this table right here. Determine the appropriate sample size. This is the first thing we need to do. How many sample size, the observation, how many observations we should take. If the standard time element to be within 5%, true mean 95%. All right, so now the Z would be 1.96 from the table or from the appendix. A is equal to 5. Now we have these elements, get appropriate bowl of dough, flatten dough, spin and toast the dough, place dough on work counter, pour sauce on form dough, place cheese on the top, place pepperoni on the top of cheese. So, and they give us the standard time, the standard deviation, and the mean time for how many times they did. I think they did 10 of them, I think 10 times. All right, so in order to find, the first thing in a time study is to find out the number of observation. The number of observation is we use this equation, which is the Z divided by A times the time divided by the average, the mean. Right, so which is basically, let's go back a little bit here. I'll show you the equation that we need to use. This equation right here, Z times S divided by A divided by X average to the power of 2. Okay, so this is what we do. Of course, Excel would be great. So work element 1 would be 11 observation, work element 2, 23 observation, work element 3, 10 observation based on the equation. In work, etc., we do all this. So Z divided by A times the standard deviation for that element divided by the the mean for that process. Okay, the standard deviation is right here. The mean observed is right here. So let's take one example here and show you how we get these numbers. So we have 5 and 95. So the first thing you want to do, you find the z value from the table. That would be equal to 196. So this is where the 196 come in, divided by 5, which is the error for the process, which is 0.05%. And now standard deviation for process 1 is 0.01. So that's where you see 0.01 right there. And now divided by the mean of the observed, which is 12, and that where the 12 to the power of 2. This is where you get the observation. Now, I think here now they did 10 observations. So now what we have to do, we looked into, so this is where the step number 5, they have to do another 15 additional cycle because they observed 10 before. So now they added more observations, and these are the observations where they have to do for each element, and they updated the mean observed time 0.15, 0.25, 0.60, 0.15, etc. Now what we need to do is to find what would be the normal time. The normal time would be multiplying the mean times the performance to have what would be the normal time. If there is a frequency, usually the frequency you multiply by frequency as well to find out what would be the normal time in minutes. And then once you find out, you add the total to be 196. These are the normal time. And now what we need to do, we need to have to calculate the standard time. The standard time here, what we have to calculate, we have the normal time times the allowance factor. So the normal time is for element 1 is 1.35 times the allowance factor, which is 1 over 1 minus 15. So that would give you 0.15 minute. And you do the same thing step by step, and that will give you 2.313 minutes to make one large pizza. In order to make in a one shift during an 8-hour day, our worker should be preparing 207, which is 480 minutes per 8-hour shift. Divide that by 2.13. This is where you get the 207. All right, so I hope this is helpful. This is how we do the time study. This is how we calculate the time needed, and based on the time needed, we could plan on the ability of the worker, and then we could maybe take it further and find out what would be the cost for each pizza here in this example, and then we could do some cost analysis. I'm going to stop right here. Thank you very much, and we'll see you in another video where we could talk about the value stream mapping. Thank you so much.